Good morning, students. Today our topic is fundamental theorem of arithmetic. This fundamental theorem of arithmetic is related with the composite numbers and prime numbers. That's why first we have to learn about what are prime numbers and what are composite numbers. Before that, you know the factors. What are the factors? Let's see. Here 24. We can write the 24 as the product of two numbers. Any two numbers? We can write this 24 as the 3 into 8. That means product of these two numbers gives 24. Here 3 and 8 are called factors of 24. These are the factors of 24. And this 24 is called multiple of 3 and 8. So this 24, this product is called multiple, and these 3 and 8 are called factors. And you know some numbers, something like 7. We can write the 7. Can we write the product of any two numbers? Yes, we can write the 7. We can write only in one way, that is 1 into 7. So we can write the 7 as the product of 1 into 7. But we can't write in any other way. That's why these numbers are called prime numbers. These numbers are called prime numbers. That means the numbers which having 1 and itself as the factors are called prime numbers. Some prime numbers, the first prime number is 2. 2 is the first prime number. We can write the 2 as the 1 into 2 only. That's why 2 has the factors 1 and 2. Next prime number 3. 3 also having the factors 1 and itself only. And next prime number 5, 7. Next prime number 11. Not 9, because 9 having the factor 3. That's why 9 is not a prime number. And 13 and so on. These are all prime numbers. What are prime numbers? The numbers which having the factors 1 and itself. Those are called prime numbers. The numbers other than these prime numbers are called composite numbers. So first composite number is 4 and 6, 8, 9. These are all composite numbers. These are all having the factors other than 1 and itself. So these 4 having the factors 1, 2 and 4. That's why these are all composite numbers. These are all prime numbers. The first prime number is 2, and this 2 is called even prime number. The even, only one even number is the prime number. So 2 is called even prime, and the first composite number is 4. So 1 is neither. Now let's take one composite number, that is 24. Can we write the 24 as a product of two numbers? Yes, we can write 24 as the 3 into 8. So the product of numbers is equal to 24, and just observe, this 3 is a prime number and this 8 is again composite number, and that's why we can write this 8 as the product of another two numbers. That is, we can write this 8 as 2 into 4. And again observe this 3 is prime number and this 2 is also prime number, and we can write this for again product of two numbers, that is 2 into 2. So just observe here 2 prime number, 2 prime number, 2 prime number, 3 also prime numbers. So these are all prime numbers. That's why if we write in ascending order 2 into 2 into 2 into 3, we can write 2 into 2 into 2. How many times? 3 times. 2 cube into 3. So this is called prime factorization of the numbers. Prime factorization, and this prime factorization is unique for every number. So this is called fundamental theorem of arithmetic. So what is fundamental theorem of arithmetic? Every composite number can be expressed as the product of primes, and this factorization is unique apart from the order in which the prime factors occur. So we can write any composite number. Let us do another number, another composite number, that is prime factorization of 140. So how can you write 140 as a product of prime factors? Just say the 140 was the first prime number. The first prime number 2. Is the 140 divisible by 2? Yes, it is divisible by 2. What is the divisibility rule of 2? So the numbers having 0 or even numbers in its units place, that number is divisible by 2. That's why this number is divisible by 2. 2 how many times in 140? Right, 70 times. Again, this 70 is the 70 divisible by 2, first prime number? Yes, because it having also 0 in its units place. How many times? 35 times. And again, is the number, is the 35 divisible by 2? No, because it having 5 in its units place. So that's why it is not divisible by 2. And the next prime number is 3. Is the number divisible by 3? What is the divisibility rule of 3? The sum of the digits of the number divisible by 3, that number is divisible by 3. Here what is the sum of the digits? 3 plus 5 is equal to 8. So 8 is not divisible by 3. That's why this 35 is not divisible by 3. And the next prime number is 5. Is the number divisible by 5? Yes, this number is divisible by 5 because it having 5 in its units place. That's why 5. How many times? 7 times. 7 times of 5 gives 35. So this 7 is again prime numbers. So we can't write this 7 as the product of any number. So that's why 140 is equal to 2 into 2 into 5 into 7. That is equal to 2. How many times? 2 into 2 we can write as 2 square into 5 into 7. So this is the prime factorization of 140. And you can try the two numbers 156. Write the 156 as the product of prime numbers. And again another problem 3825. 3825. So let you try these two numbers. Prime factorization of the two numbers. Now let's find the HCF and LCM of two numbers by using prime factorization method. Now prime factorization method, HCF and LCM of 12 and 18. First write the prime factorization of 12. So can you write prime factorization? First prime number 2. How many times? In 12, 6 times. Again 6 is divisible by 2, that's why 3 times. So this is the prime number. No need to do. Therefore 12 is equal to, the prime factorization of 12 is equal to 2 into 2 into 3. And prime factorization of 18. How many times? First 2. Yes, the 18 is divisible by 2. How many times? 9 times. Is the number divisible by 2? No, because 9 is an odd number. That's why 3. Next prime number 3. 3 how many times? 3 times. So again this is prime number. No need to do. So 18 is equal to 2 into 3 into 3. And we can write this 2 into 2. 2 how many times? 2 square. 3. And we can write 18 as 2 into here 3 2 times. 3 into 3 3 square. Now this is the prime factorization of 12 and this is the prime factorization of 18. Now finding the LCM and HCF. First we can find the HCF of 12 and 18. So HCF of 12 and 18 is equal to, here HCF is the, just find the common factors of these two. 2 is common factor and which having the least power between these two. So it having the least power, that's why we can write 2 into another common factor 3 and which is the least power, having the least power 2 into 3, 2 3s are 6. That's why the product of the common factors, which having the least powers is HCF of the two numbers. So HCF of these two numbers is 2 into 3 is 6. Now LCM of 12 and 18 is equal to, now LCM means the highest powers, the factors of highest powers of each factor. So all factors, not only common, all factors, each factor. That means here 2, what is the highest power? So it having the highest power, 2 square. And 3, which is the highest power? This is the highest power, 3 square. So there is no any factors. So we can write all factors, each factors which having the highest power. 2 square 4, 3 square 9, 4 9s are 36. So 36 is the LCM of 12 and 18. So HCF of the two numbers is the product of least powers of the common factors, and LCM means the product of each factors which having the highest power. So this is the finding HCF and LCM by using prime factorization method, and you can try. Finding the LCM and HCF of 12, 15, 21. We can find the LCM and find the LCM and HCF of 12, 15 and 21. 12, 15 and 21. And again 72 and 108. Find the LCM and HCF of 72 and 108 by using prime factorization method. You can try these two problems. Okay, let's do the third problem in exercise 1.2. Check whether 6 power n can end with the digit 0 for any natural number. So is the number 6 power n end with 0. That means in its units place, last digit is 0 or not. You have to check that. Before that, let's see what about the prime factorization of the numbers end with 0. Let's see some numbers end with 0. Let's see 100. So is end with 0. Let's do the prime factorization. So first prime number 2. How many times? 5 times, 50 times, and again 2. How many times? 25 times. Again this number not divisible by 2 and 3. That's why next prime number 5. 5 how many times? 5 times. So 100 is equal to 2 into 2 into 5 into 5. That means 2 square into 5 square. So this is the prime factorization of 100. 2 square into 5 square. Let's do another number. Let's take another number, that is 70. That is also end with 0. This prime factorization of 70. 2. How many times? 35 times. So this 35 is not divisible by 2 and 3 also. That's why take 5. 5 how many times? 7 times. So this is the prime number. So no need to do further. So 70 is equal to 2 into 5 into 7. So this is the prime factorization of 70. So these two numbers are end with 0 and this is the prime factorization. Just observe. So in this prime factorization there are two prime factors 2 and 5. So in this also two factors 5 and 2. So that's why the numbers end with 0 having the prime factorization. In the prime factorization 2 and 5 must be there. That's why now we have to check this 6 power n. Is the 6 power n having 2 and 5 in its factorization. So what is the given number? 6 power n. Let's do the prime factorization of 6 power n. Power n is equal to, you can write the 6 as 2 into 3 whole power n. So that means 2 power n into 3 power n. That means 2 into 2 into 2 how many times? N times. 3 into 3 into 3 how many times? N times. So that's why, so in the factorization, prime factorization of 6 power n, there are only two prime factors, 2 and 3. That's why there is no 5. So to be end with 0, so this 6 power n must having 2 and 5, but there is no 5 here. That's why it is not end with 0 for any natural number n. So to end with to end with 0, 6 power n should have 2 and 5 in its factorization. Prime factorization. To its prime factorization. But there is no 5. That's why therefore 6 power n can't be end with 0 for any natural number n. So 6 power n is not with not end with 0 for any natural number n, because they have been only 2 and 3 as the prime factors.